Am I an ops engineer? Like, what?
If that third thing fails, maybe that you don't want to rerun that LLM call in the beginning if it was fine, because you're also then wasting money and you might be doing things twice.
Hey, stuff breaks sometimes. Just try it again if it doesn't work, right? Like, I'm not setting up RabbitMQ. I'm sorry. And it is really fun to go on an internal tools infrastructure rabbit hole and just see what you can build and see whether you can get something running. But generally speaking, that turns into a project pulling you away from shipping the things that a customer would pay for.
You start there, and then the complexity just kind of snowballs. This needs to exist. There needs to be something better.
And the reason that I got so excited about services like Inngest, when I looked at it, I was like, wait a minute, I already broke my functions into these composable pieces. So if I put them inside of these ingest steps, I'm done. When you start plugging services together, right? You are going to be making API calls. You're going to be sending messages back and forth. Maybe you're doing some real-time stuff. You need to be confident that when you send that message, it's going to get where it needs to go. And when you start stringing lots of services together, you're going to say somebody submits a form, and then that form needs to go to a database, but maybe it also needs to update your Slack channel. All of these things have to happen in sequence, and they depend on each other. So what happens if, say, there's a blip in the network and your database call fails? How do you retry? How are you going to manage that? This stuff is really, really hard, and it's really complicated if you don't have the right tools. And so I'm going to bring on my guest today, who's been thinking heavily about this space for a while now, and is going to talk a little bit about how we think about this, how we can solve this, and what he's been working on that'll help us solve it. So please welcome to the stage, Dan Farrelly. Dan, how you doing?
Hey, Jason, how you doing? Pretty good today.
I'm so happy to have you here. You've been building stuff that has been scratching at an itch that I've had for a long time, which is I like to plug lots and lots of things together. I love making nice, complicated workflows, but the pain of doing that when it goes wrong, right? Like the happy path is always great. Like, oh yeah, I do this, and then it goes here, and then it does that, and then this thing happens, and you feel like a genius, and the whole thing falls over, and now you're on manual debugging duty. So I guess maybe first and foremost, let's talk a little bit about who you are and sort of your path to where you are today.
You teed up a lot of great stuff, so we're definitely vibing already on kind of where Inngest fits. But for me as context, before I started Inngest with my co-founder Tony, I worked as a CTO at a company called Buffer. It is a SaaS app for marketing teams to schedule, analyze, and respond to like social media posts. I started there actually as just a full stack engineer, and then kind of took on more responsibilities, ended up kind of digging in from like the lowest level of the infrastructure all the way to the front end, thinking about systemizing all the bits, and eventually became the CTO there. And that was kind of my mission at that point, was to, kind of already back in say 2016, 2017, was thinking about, we were like a small team with a very small like infrastructure, friendly like group. And we were really thinking about like platform engineering back then. And, and I think like before maybe it had a term, not sure. Really, how do we enable our product engineers to do the best work? We had like a ton of great product engineers, and I always wanted to figure out how do we make them do their best thing and deliver great products. We were a product first company, obsessed with the user, always caring about the user experience. So I kind of brought that into like down the stack, being like, how can we spend disproportionate amount of time focusing on the product that we're building and not all the stuff below? So it was always about enablement. And that kind of like lined me up for where I was like thinking in my head, like what the next stages were of this problem. And then I happened to reconnect with Tony, my co-founder, after a few years. And we had kind of similar thoughts in the space. But yeah, I guess we started Inngest back in 2021. And kind of that was when we started digging in on the problem.
And so Inngest then is sort of an extension of problems you were solving when you were at Buffer.
Yeah, completely. Both Tony and I had very different experiences. He was building for a healthcare startup, and I was building a SaaS startup. And we both had seen like similar flaws, just in different problems and different use cases. So it definitely is an extension of like, where are things going over a long enough period of time, right? During the, almost decade that I spent at Buffer, we saw a big range of changes, right? In the 2010s, there was a lot of changes that happened in software, right? Product was built on Backbone and like CodeIgniter originally. And, the infrastructure was pretty rudimentary originally, but then we saw Kubernetes, which brought more complexity to kind of the infrastructure side of things, but it also offered the ability to layer on your own custom abstractions on top of the infrastructure. So, I think it just kind of is a continuation of what was happening there. Tony, on his side, he was working at a healthcare startup and was building kind of complex flows that he had to, similar to what you said in the intro, hand roll a lot of these distinct cases that were required for, say, HIPAA compliance. They had to trigger an event and have an audit trail for that. They always needed to be able to understand what happened in the system for HIPAA compliance. Also, of course, being safe for PII. Trigger, say, a delivery to happen, but then if something didn't happen after X number of days, if that, say, patient didn't approve and say that I received this package, they needed to do something about it. So there was always a trail and a thing of actions that needed to happen to follow through. And for his use case, he had seen that everything prior to this was building everything from scratch, bespoke, like I'm going to store this state in the database and then I'm going to have a cron job that goes and checks the status of this after days. So you're building the same thing again, but there should be an abstraction above that allows you to kind of define the business rules and the business logic and not have to worry about all the pieces. So more of a general purpose. So like we came at it from two different angles. At the end of the day, we both aligned on like, this needs to exist. There needs to be something better.
Yeah. And so, the way that, as you said, people hand roll these things. And so I think the first step that somebody would take would be, as you said, you got a database, maybe you're setting up a cron job. But as you get more services involved, you start getting into these retry situations, third-party services. It starts to get a lot more complicated. So traditionally, how have companies solved this when they're rolling it in? Like, what are some of the tools that you'll see in the stack?
Yeah, so I think it also is sometimes useful to think about where Inngest fits in the stack to kind of how I think about it and then explain what would have been there kind of thing. If I look at like the stack of a modern application, if you're building, maybe previously it was a web app, an API, and a database, for something simple, a CRUD app maybe. And when I see this now, there's a fourth component. And I see that it's Inngest, right? It is an execution engine that allows you to do the more complex things in your application that are not achievable from the client, from a synchronous API, or from a stateful database. The stack that would exist below this is a web of, depending on what you need, a layer of queues, choose your own version of whatever you want here, spinning up that infrastructure, whether you're running a queue yourself on a machine or using something that is like a cloud provider solution. Then you're spinning up workers, and then you are defining the logic on that workers, right? How you pull for messages, how you then, as you mentioned, handle retries. What happens if this fails? And then from there, it is, say you have a complex flow, like the one that I described with Tony's previous company that he led was, you have a queue that starts the first job, does some work. Then now you need to define a database schema to store state of where that job is. And then you have to define something that then updates that state later or has a cron job now. And then you have another worker and another queue that says, I'm going to ping this and say, clean this thing up and do something else if this works. So now you have two queues, a cron job, two workers, some state in the database. And this is how people traditionally like build these systems. And, there's layers and layers and deep to the problem, but generally like you start there and then the complexity just kind of snowballs. And then you spend half of your time trying to design the system, which can be honestly fun for some people, but also doesn't get you closer to like something that is usable.
Right.
So you can get lost in there for months.
Yeah, I mean, I think it sort of points to something that I talk about a lot, which is the idea of, when you're working at a company, you don't necessarily want to be engaging in hobbies. You want to be building things that are actively valuable to the customer that you're trying to serve. And it is really fun to go on an internal tools, or a infrastructure rabbit hole and just see what you can build and see whether you can get something running. But generally speaking, that turns into a project that's pulling you away from shipping the things that a customer would pay for. Like they will pay for stability, but they've asked for, XYZ feature support. And if you spend 6 months building infrastructure stability, you are not shipping on features. And that can cost you in the long run. And the other thing that I think about with this is that in addition to just the overhead of having to spin up these other services, it tends to, especially for say like a front end heavy team that's, maybe you're building in a TypeScript stack or you're more of like a full stack kind of JavaScripty house. When you start getting into these backend services, you either have to hire a specialist or you find yourself needing to learn like RabbitMQ or Kafka. And then when you're deploying those services, it's not like deploying front end services. You got to have a whole different deployment pipeline, and there's different ways to manage the servers and all these really not necessarily complicated, but like just chores, like things you got to go learn. You got to figure out how this system runs, how to make it resilient, how to make sure that you're not going to have it fall over when you end up under load, or that when you restart it, you don't dump the active jobs that are incomplete, and like all these really interesting little problems that happen that if you've never done it before, it's like, oh God, it's daunting. It's really daunting. And so I know that this is where you and Tony started. This is where Inngest came from. So maybe let's talk a little bit about, how are you approaching this space from the technology side?
I guess, from this, like originally what we wanted to start with was you made a point about this kind of front end team heavy kind of thing, or full stack teams, which is like, it's been happening in various teams for years, but like this full stack product engineer kind of good on the front end, solid on the back end, maybe on the system side is a little bit like, is where you might be dipping your toes. And I think when it comes to that, we saw this group and said, you know what, let's see where they are, right? You know what, some people are deploying their apps to serverless, right? Pick your serverless front end system like say a Vercel. And, how are you deploying anything in the background there that's running durably? So we originally approached as saying, what's the least common denominator? Let's make something that works for serverless, then it'll work for everything else. So it'll work on servers too, because typically in these systems, you have to run a worker. So now you're like, you've moved out of serverless and now you're say running something in a container. Maybe you're scaling those horizontally. You have a fleet of containers. Maybe you're dipping in auto scaling. Maybe you're not getting that far. And you're kind of having to manage all the stuff that happens in the background that you have no visibility on, right? Because that's one thing that's very easy is like with an API, you ping the API, request, response, you see feedback, you can log a failure. With things that happen in the background, it's a little bit more opaque. How do you give feedback to the user? How do you figure out what happened later? How do you retry and whatnot? So we originally started and we looked at serverless and said, let's make something that works serverless friendly. So we defined basically like our original approach, and this is still our main approach right now, is you can define in your API server ingest functions that are running, and you define the event, any flow control, which we can talk about, and then just a handler. And maybe you break that function into multiple steps, turning it into maybe a more complex workflow. But you take that, you ship that on your API, you tell us where your server is. And ingest basically is the engine that handles everything from there.
What's really interesting about this, and the thing that I think is important to specifically call out about a service like Inngest, is that when you are a front-end developer, you start putting together these workflows. And the first time that you do it, when you're early in your career, you'll create a function and you'll do everything inside of that one function. And then you start to learn how to, break up each action into its own function so that you can separate the code, make it a little more reusable. Then you start to realize that like certain functions could actually be put in the background. And so you start to think about, maybe I can offload this to different places. Your application gets more complicated. Now you're talking to databases, you're talking to third-party services, you're talking to, asset managers, you're talking to user systems and notification systems. Maybe you've got a logging system. And each of those things now is living inside of these little functions. But those functions then are now still kind of like on your system, So it's hard to background them. They become blocking. You've got a long running logging call. You're adding 150 milliseconds for really no reason that the user cares about. And so then you start looking at offloading this to other places, which is where you start to hit these problems where you're like, okay, so in order to solve this, I need to go get a queue, or I need some kind of backend system or whatever it is. And usually it gets daunting at that point. You don't want to do it. And the reason that I got so excited about services like Inngest is that when I looked at it, I was like, wait a minute. This is just like, I already broke my functions into these composable pieces. So if I put them inside of these ingest steps, I'm done. And it just sort of works, right? And so what I think is so powerful about this is that, yes, you have to start thinking about things as atomic steps. I mean, I'm more or less like, you're kind of building a state machine, right? Which, and if you think about things in that way, it's okay, same input, same output. And if that's the case, you can start to orchestrate these things. But then putting them into ingest isn't like I'm learning how to do a YAML configuration or I'm learning how to deploy a container. It's like, wait a minute, no, I was already writing these utility functions. Now I'm just organizing my utility functions with a little bit more of like, here, here's where it starts, here's where it ends. And I get all of this magic, right? And that was when I really got excited, because I realized just through my own coding best practices, the things that other engineers have been encouraging me to do, the things that my peers are saying, hey, write cleaner code, here's some tips for doing that. It's like, oh, I'm pretty much already there. Like, I don't have to learn a whole new system. I don't have to learn a new language, and I don't even have to learn a new deployment system. I just had to add a new serverless endpoint, and I was up and running with this whole queuing, retried, safe, multi-system orchestration. I was like, oh man, am I an ops engineer?
Yeah, and that's the goal, right? Is you don't need to, you have those functions broken out. You're already in your code base. Instead of having to like define a worker and then a new service, and then like you're building Docker files now, you're in that kind of realm, is you just drop it into your existing code base, right? And the less that you need to think about, the better. And that was when, we were a team of 3 at that point, and we like built the first kind of like, what does this SDK look like? That was when we came up with the step.run primitive. And we were like, all right, you could make some higher level abstraction that adds more complexity or this and that, or really over define it. Like you said, is like starting to get into YAML of all these like custom DSLs and whatnot, and different frameworks that you might see. But what's simple is like, there's steps in a workflow. You wrap it in step.run. It runs, encapsulates your logic that runs. And that's our like the lower level building block. And that's like all you really need to know. And what's great about that is like, typically, okay, you're just going to push something in the background. But as you run these complex things, you mentioned at the top about more often than not, we're building complex applications. Rather than a decade ago, which maybe had less integrations, you're building CRUD apps, more that might be more fully contained. Everything is intertwined. And of course, everything today is hidden in LLM at some point. So you're hitting all these different stages, and something can fail. So this step primitive is basically wrapper to say, hey, this is a side effect, or this is something that is running. Execute this. When it's done, never execute it again. You talked about idempotency earlier too. You alluded to it. And then run the next thing. So, but if that third thing fails, maybe that you don't want to rerun that LLM call in the beginning if it was fine, because you're also then wasting money, and you might be doing things twice, right? You may
and you're wasting time.
You're wasting time. You're wasting resources. So that step primitive that we have is just the building blocks of kind of building these like durable functions or durable workflows. And I think that is like, hey, okay, I can just import my function here and just use it, just wrap it in a step, and I get this. And that's that. And of course, we expanded it in different ways for different types of primitives, but that's the foundation of what you're talking about.
And I think here's the piece where the light bulb really went on for me. As I'm writing my applications, I'm already writing a utility function that is like save to database. And then I've wrapped up the logic for how I save to a database inside that function. And then I return back the new user object or the new record. Then I'm going to take that and I'm going to say, send a notification to Discord that thing happened, right? So I'm going to enter that new record. I'm going to drop that into the thing. And so I was already breaking up all of these things into these atomic steps where I expect one input, one output. So by all I had to do to adopt ingest was say step.run and then put that function inside of that step. And then when my database call succeeds, but the call to Discord fails, I don't have to do a try catch. I don't have to write logic for exponential back off. I don't have to, double check that the database record is there before I move on to second step. I just know that Ingest has already done that for me. And I'm able to then say, do this workflow. And it's like, I already did this workflow, but step 1 is done, but step 2 is not. Let me skip step 1, take the output from step 1, drop that into step 2. And okay, that time it succeeded. Your workflow is done. Congratulations. I just get a dashboard that shows me like, hey, your thing is done. That's the other thing that I think is really cool about this is that one of the things that's really hard about debugging these complex workflows is that you have all of these steps. And when something goes wrong, it's not always immediately clear where the thing went wrong. And this is something that I think, again, when I saw this, I was like, oh my God, I'm so glad I don't have to roll any of these things myself, because you just have a nice little UI in Ingest where I can see here's the run that's happening and here's each of the steps. Okay, this is the step that failed. Let me click on it. Okay, here's the error message that came out of that step. Here's the input that went into that step. Now I can just kind of go in and debug that one function that failed, as opposed to trying to figure out like, okay, let me console log here, oh, here's where it's wrong. It's these little things that just make you more effective. And that would be really hard. Again, like if you're repeating that database call every time you debug, that's a really potentially destructive thing to be doing if you're trying to debug production data. And okay, now you got to pull a copy over to the development database so that you can run it safely without like polluting the production data. It takes a ton of time. Whereas in Ingest, you can just look at it and say, oh yeah, that record's in. We see that succeeded. So we don't have to worry about that. It's this next step that failed because the return value changed shape from the database. And now it's, causing our second step to fail. Oh, we can fix that. No problem. Right. It just sort of made my life easier as somebody trying to orchestrate these things, because you just get this super high visibility at a very granular level, like a step-by-step level. Is that the sort of thing that when you were building it, was that like a thing one, or was that like I guess the way we did this made that kind of easy?
No, we had a lot planned early on, and we kind of looked at we took a step back of like, all right, we built these systems. What do you need to operate them, right? What do you need to run them? What do you need to debug them? And the model definitely did make that easier, right? Every step sends commit something to our system, and we have that record. We also have when it fails, we log that. So we get this observability for free, basically, when you run, with Ingest, and, rewind to where people might have been prior to Ingest using something like that, using something like Ingest. It's like, maybe you're dumping logs to a server. Maybe you're piping them somewhere and you are parsing them. Maybe you're giving everything a job ID. You're really good at structuring your logs. You're still now in the land of parsing logs or manually tracking job state in a database, which is then you're kind of building your own system. Or maybe you were instrumenting with some sort of observability tool, right? Like a Datadog, which then means you still need to figure out how you're doing this, what you're logging, what that bill looks like. It shouldn't just be like that. You should just be able to get it right out of the system, right? It should be clear. And I think one of the key things that you mentioned is in that case is when you're debugging something and you see a failure, it could be an isolated case, which is great, which then you say, all right, we can fix something over here in the Ingest dashboard because we know your code and where it's running and what happened. We can rerun. You can just click it right in the UI. It's like, you know what, this is not a problem anymore. I fixed this. Click rerun, everything's fixed, everything's good. But often what also happens is you're deploying a bug or there's something that changed in a library, and let's say 10,000 jobs fail in a short period of time, depending on your scale. Maybe it's 1,000. And typically, you might have to work with dead letter queues, or you might have to say, let me just scrape all my logs. Now I'm going to replay something, or I'm just going to communicate to my users, I can't fix this, right? It's a terrible situation to be when you're recovering from an incident. But with Ingest, because we know the job status for each thing and we save the inputs for each, one of the things that we have built in is recovery tools. You could say, all right, give me these. Between these times, I want to replay all of these functions that failed because I fixed the bug, I tested it out in production, it's there. Or also ways where you can copy payloads and send them to your local environment and run the function and step through everything locally on your machine to kind of debug, like you said. So, these types of things, like to be able to build these recovery tools, whether you're bulk canceling, you're pausing a function while you fix something and then unpausing it and letting everything rip, or you're replaying everything bulk, you need like the actual system itself, we believe, needs to be aware of this and have this data. Mm-hmm. If you offload this to, say, a third-party observability tool like a Datadog or something, you're still kind of in that boat where you're like, I need this data out of Datadog, and then I need to put it in my system and then figure out how to replay. So, I think that's kind of a key thing that we saw, that when you're building systems like this, things happen, that you're going to need it. So we knew that we needed the data so that you can self-fix it and you can have these recovery tools. So
right.
I think it all kind of flows into the same thing that allows just devs to get things done.
The thing that I love about this approach to managing the complexity of modern apps is that we, as the people building the apps, want to be focusing on the specific bits of logic, right? And maybe we need to do some step-based stuff where we're going through and updating a lot of different systems and services, and we need to be able to, we don't want to have to think about retries and the, like duplicate data or all of the complexity that happens there. Maybe we're doing something where we need to wait for user input and we need to be able to pause a workflow and wait for an event to happen so that we can then continue once we get like a confirmation or once a user completes a task. Maybe we need to do something that's real time. It doesn't matter what it is. The way that you've built this system and the way that Inngest is set up to work is that I get to write the flow that I want to write as a linear thing. And I say, do step 1, do step 2, wait for event, do step 3, send this real-time event back to the browser, and then wait for that event so that I can do step 5. It keeps going. And from my standpoint, I'm just writing TypeScript, right? And that to me is such a powerful way to level up any complex workflow and to remove all of these things we were talking about, managing queues, managing infrastructure, managing all of the things that make this stuff hard, just kind of becomes something that we don't have to deal with anymore. And to me, that's about the best way, especially, I'm running, I use Inngest on CodeTV, and there's no way I would have the ability to build these backend systems. I'm one developer and I've never built those kinds of things before. If you told me I needed to set up a Kafka queue, I would just add a footer on my site that says, hey, stuff breaks sometimes. Just try it again if it doesn't work, right? Like I'm not setting up RabbitMQ. I'm sorry. And so I think that to me gets me really excited about what's possible with this stuff. As we get to the end of our time here, Dan, is there anything you want to end with?
You said, you made a lot of good points. And I think overall, like as an engineer myself, our team is all engineers. I'm sure the audience is all, product engineers too, kind of in similar places. It's hard to build applications these days. Everything is getting way more complex. And of course now, everything has the demand of bring in AI into every product. So, we didn't set out to build the product for AI. Mm-hmm. But I think one of the things is that like the demand to move faster is real, right? The demand to be able to like, I need to ship something that is really cool, right? You can build so much faster now on the code level, but what about the infrastructure? Claude Code doesn't help with that, at least yet. When it comes to this is like, we believe that what we want to do is enable all the engineers like yourself or teams that are heavily product engineering to do more and ship better products, because there is, with AI, it's hard to have a real moat when you're building products these days. So how do you iterate faster, build great products, for your users? That's what they care about, right? And how can you do it without less headaches and less like getting caught in the weeds with all these things that aren't actually moving your business forward and may actually cost you longer, time to maintain long term, more headaches. So, when it comes to this is, I think, I see Inngest as the companion to that stack, like I mentioned earlier, right? You got your API, your database, your web app, you got Inngest, and you can build anything. So, this is, I think, where we're at. And, the system that we've built is generic too. You run it on any different cloud from Vercel to a server and any language, right? We support TypeScript, Python, Go, and got more on the go, Java as well. It's generic. It can work on anything. So we have a lot of polyglot teams that are working together with multiple languages all within the ingest system, and it's making things a lot simpler for folks. So that's what I, kind of leave people with.
I think that's a great thing to leave people with. If you want to learn more about Inngest, go check out inngest.com. It's INNGEST.com. Dan Farrelly, thank you for spending some time with us today. If you enjoyed this podcast, make sure you go ahead and subscribe, add it to your podcatcher of choice. You can listen to us on Spotify, on YouTube, wherever you get your podcasts, and make sure you tune in for more episodes just like this. If you want to see the pair programming session, head over to the CodeTV.dev website and search for Learn with Jason. The Dan Farrelly and Inngest episode will be up there soon.